This is Mrs. O'Neill for AP Chemistry, Chapter 11, Section 2, Part 7, the wrap-up. Like I said, we're just going to wrap things up, making sure that you're understanding the comparison between the four IMFs. So these are the four IMFs again, the LD, the dipole-dipole, hydrogen bonding. I always like to put bonding in quotes because it's really not the bond we're talking about, but it's that force of attraction between hydrogen of one and NO or F of another molecule. And of course, then the ion-dipole. And again, I like to show it to you as the weakest to the strongest. So pause the video and make sure you're understanding the weakest IMF to the strongest bond. So I also kind of chopped this up where these are your IMF forces dealing basically with one kind of substance in the pot. Then you have this ion-dipole force, and this is why I kind of gave it its own little category, because this really deals with, again, an ion from one substance and a polar molecule from another substance. So that's the difference between these two sections. And then this last section would be the intra-bonds, the actual bonds between the atoms within the molecule. And of course, your ionic is going to be stronger than the covalent bonds. So nice little flow chart. Again, if you want to either take a snapshot picture of that, this also shows you that van der Waals force of attraction, if they ever mention it, deals with both dispersion and dipole-dipole molecules. And we want to remember that anytime we have something like hydrogen bonding, that means we have dipole-dipole and dispersion also in that same molecule. So pause the video, fill in the blanks. Again, read as you write. I can't stress that enough. And hopefully this makes sense to you now. And when we're talking about that AP exam and they're talking about LD or especially LD forces, this is things that you want to take notice of, or these are the words you want to use to explain why one LD molecule is stronger than another LD molecule. We want to talk about its size. We want to talk about how it becomes a temporary dipole. We want to talk about the electron density. Again, as you get bigger in size, you have more electrons. So your density is more, and if you have more electrons, that means you have a higher polarizability. If you become more polar easily, the more easily you become polar, the more easily you become a dipole, which means your strength is going to be stronger. Your LD forces are going to be stronger. So with polarizability, again, really, really important as you increase molar mass, as you increase those electrons, as you increase the complexity of that molecule, you're going to increase the polarizability of that molecule. So again, nice little flow chart. Again, if you want to take a screen snapshot of this or whatever, but this is really a nice flow chart comparing all of those IMFs. And again, I did it in increasing strength. So we have our dispersion or LD forces all the way to ionic bonding. I believe the one thing they're missing here is that covalent bond. So not sure if there's something you want to write in there. I believe in your notes, there's a spot that says write any other information you want to. So here I'm just going to say, I'm going to keep my mouth shut as much as I can. Pause the video, read this information. It's a bunch of slides with information. And again, I don't make you read much, but this is going to be a nice wrap up of all of these IMFs. Again, pause and read. Do we remember this when we talked about polarity? Hopefully that makes sense, because the closer they are, the more non-polar they are. So the farther away those elements are on the periodic table from each other, the more polar they're going to be. And why we need to know that information is because sometimes they don't give us electronegativity numbers to actually do the math. So we're just going to have to use our periodic table to decide what's polar or non-polar. Again, hydrogen bonding, not a big fan of bond, of that word bond. Remember, that is just the little force of attraction between two molecules. And this talks about, again, those Coulomb's law, and that effective nuclear charge. For the AP exam, again, pause and read. So can we do a practice problem? Again, halogens, you got to remember what group number halogens are. Hopefully you figured out that halogens are group 17. Again, the group starting with fluorine. Now can you increase the boiling points and why and explain your answer? So hopefully this makes sense. Again, pause and make sure you're understanding. All right, we will see you in class for the bookwork of this section and answer any questions that you may have.